Hello everyone, my name is Bruno Paini and I am a PhD student in the University of Windsor, under the supervision of Dr. Srikanta Das. This presentation will discuss the experimental procedures regarding the testing of sustainable basalt reinforced concrete posts. Basalt fiber reinforced polymer is originated from the igneous rock called basalt. Some examples of fiber-reinforced polymers are glass, carbon, aramid, and basalt. FRP materials are relatively new, though some products are already available such as rebars, fabric, mesh, chopped fiber, and insulation boards. The greatest benefit of FRP materials over common steel rebar is the environmental impact. There are no harmful gases or chemicals resulted of the roving process of BFRP rebars. As a result, basalt rebar can be considered a sustainable, green, and environmentally friendly product. BFRP, as other FRP materials, also present high strength-to-weight ratio, corrosion resistance, high fatigue resistance, fire resistance, and they do not conduct electricity. Very little research is available regarding the basalt FRP rebars as concrete reinforcement, so the study is intended to explore this application of the basalt rebars. The strength of the rebars was tested through direct tensile tests in accordance with ASTM D7205. The test setup is shown in these two figures. The digital image correlation technique, or DIC, was used to extract the strain data. This technique consists in taking pictures from the spagle pattern applied on the surface of the specimen and then compare the pictures frame by frame with a computer software. The tensile properties of the tested rebar are presented in this table. Compared to the conventional rebar, BFRP rebars presented an ultimate stress of about twice as large, with an ultimate strain of 2%. The modulus of elasticity in all the rebars were in the order of 50 gigapascal. The test matrix consists of 3 specimens for each of the 3 rebars configurations. So there are 3 specimens with one 14 mm BFRP rebar located in the center of the post cross-section, 3 specimens with one 20 mm BFRP rebar also located in the center of the cross-section, and lastly 3 specimens with 4 10 mm BFRP rebar, one in each corner. The concrete was cast from a ready mix with a specified compressive strength of 35 MPa. The specimens measure 80 mm in width, 80 mm in depth, and 2000 mm in length. This picture presents a real application of posts similar to those tested in the lab. The BFRP reinforced posts are an environmentally friendly alternative to the steel or wooden posts currently in use. Basalt FRP's prices are comparable to glass and significantly cheaper than carbon FRP. A 3-point bending test setup with a pin roller configuration was used for all specimens. The load was applied through a load jack and pump. The distance from the supports to the point of application is 0.75 meter. Under the point of application, a 25 mm LVDT was placed to record the displacement. A load cell with 50 kN capacity was used to record the load in all tests. The crack pattern and failure mode were similar in the different specimens that had various rebar configurations. In all cases, the failure is due to the concrete reaching ultimate strength and not due to rebar ultimate strength. The test results are summarized in this table. All the 3 rebar configurations presented similar results for maximum displacement, load, and cracking moment. The maximum displacement ranged from 18 to 21 millimeters. The maximum load from 7.5 to 8.5 kilonewtons, and the cracking moment ranged between 5 to 7 kilonewton meter. It is worth mentioning that the code calculations performed in accordance with CSA A23.3 and CSA S806 matched the experimental data, and the moment capacities from the code proved slightly conservative. With the test data, it is possible to plot load deflection curves for the different rebar configurations. The 20 mm rebar presented a steeper curve with some yielding plateau, whereas one 14 mm rebar and four 10 mm rebar presented very similar results, which shows that the number of rebars in their position, being one in the center versus one in each corner, are not relevant in this case. The tests were halted when the load dropped by more than 20% of the maximum value. Here are the three curves for the different rebar configurations combined into one graph. The load deformation data shows that the capacity depends mainly on the compression strength of the concrete, which makes BFRP rebar suitable for this application within the scope of this project. Despite the lower elastic modules of BFRP rebar, the deformability for these specimens were within acceptable values. The authors would like to acknowledge and thank the contribution from Meta Group and the Natural Sciences and Engineering Research Council of Canada.